Transient analysis using modal superposition principle is demonstrated in HyperWorks 2022 and solver OptiStrut. Mode superposition principle is a powerful and efficient technique. It dramatically reduces the dimensionality of the problem and therefore computationally very efficient for large problems. In this method, response is obtained by superposition of normal modes. Larger the number of moves, more accurate results. Transient analysis modal technique is demonstrated on a cantilever beam. The beam is excited at the tip a half sine pulse of 50 millisecond. The beam cross-section is 20 mm by 3 mm and a length of 500 mm. The material of the beam is structural steel. Steps involved in transient analysis is shown here and grouped into 5 categories. Model preparation, which involves creating geometry, meshing, creating material and assign material to components. Creating transient load. Transient load is defined by a time history curve which is scaled by Darrieau load definition. Creating BC fixed end, one of the edges of the beam is fixed. Defining damping and other control cards, this groups of commands define damping, output format and output quantities. Creating load step, create load step, transient modal. Followed by running the model and viewing results. Creating geometry. Go to menu. Click on geometry. Click on rectangle from the shapes. Left click in the workspace and drag it. Click on the fill shape that will make it surface. Enter the value of width, say 500 millimeters. Enter the value of length 20 millimeters. Right-click in the workspace and click on the green tick. Generating mesh. Go to menu, click on the mesh. Select General 2D Mesh. Select the beam by clicking on it. Enter the value of mesh size. Click on the mesh. Mesh the sizes can be adjusted by putting appropriate number of elements. Right-click on the workspace. Click on the green tick. It completes meshing. Creating material. Main menu, click on the model. Click on materials, the material form is opened. Enter a material name. Let the card image to be mat1. This card image is for isotropic material. Retaining the default values of material properties. Young's modulus value as such. Poisson's ratio as such and also. Density. / Creating properties. Click on properties. Enter a name. Card image, shell. Browse the material defining property. Enter thickness of the beam, T equals 3 mm. Close the form. / Assigning properties to components. Click on the small arrow. And click on the 3 dot next to property and select the property. / Click on the component. Select the component in the workspace. Click the green tick. Now it completes the model preparation. Creating transient load. Let us first create time step for integration and total simulation time. Right-click in the model browser. Create load collector. Enter a suitable name.
Change card image to step. Enter 10,000 total number of steps. Enter 0.001 as the integration time step. Leave other fields as such. Slash. Creating a curve for transient load. Click on the model from the menu. Click on the curve slash. Click on End to add a curve. Name the curve. Copy-paste the half-sine data from the Excel. Enter 0 for remaining simulation time. Change the curve card image to tabled 1. Slash. Slash. Defining the load location and direction of dynamic load. Right-click in the model browser. Create load collector. Enter a suitable name. Leave other entries of the card to default. Click on Analyze. BCS. Constraints. Select Nodes/Nodes. Change load types to Darius/. Retain the only applicable degree of freedom and direction. Slash. Click Create. Click Return. Applied load is for each node selected. Creating load step input for dynamic load. Right-click in the model browser. Create load step inputs. Enter a suitable name. Config type, dynamic load time dependent. Type, load 1. Excited, point to Daria load. TID, point to the time history curve of the load. Slash. Leave other entries of the card to default. Creating load step input for modal analysis. Right-click in the model browser. Create load step inputs. Enter a suitable name. Config type, real eigenvalue extraction. Type, eigreal. V1, 0. V2, 300. All the modes between V1 and V2 is considered in calculating the response. It completes the second group of commands. Creating BC fixed end. Right-click in the model browser. Create load collector. Enter a suitable name. Leave other entries of the card to default. Click on Analyze. BCS. Constraints. Select Node/Nodes. By geometry. By lines. Select the line. Click Add to Selection. Change load types to SBC. / For fixed boundary condition, set all DOF 0. / Click Create. Click Return. Fixed end BC completes. Defining damping and other control cards. Click on the model from the menu. Click on the curve / Click on End to add a curve. Name the curve. Enter 2% damping ratio up to 100 Hz and 1% till 300 Hz. Change the curve card image to tab 1. / Create node set for output, nodes on which the output will be obtained. Right-click in the model browser. Create. Set. Enter a suitable name. Card image, set 1. Select nodes on which response is required. / Control card global _output request, defines output quantity, displacement etc. On the panel choose Analysis Radio button. Click on Control Cards. / Go to Global Output Request. Scroll to Displacement. Choose Form 1, both. Option 1, SID. Click on SID button twice and select Output Node Set. Click Return. Control card output, defines out file format. On the panel choose Analysis Radio button. Click on Control Cards. Click on Output. Enter 2 in the number of outputs. Change atomsum to high trans. Change atomsum to H3D. Set frequency to all. It completes the required control card definitions. Creating load step, transient modal. Right-click in the model browser. Create. Load step. Enter a suitable name. Analysis type, transient, modal. SBC, point to fixed BC. Load, point to load step input for transient load. Method, struct point to modal analysis load step input. Step, time point to time step load collector. Damping, struct point to damping curve. Running the model. Click on the Analyze from the menu. Click on the Run, the small arrow. Choose a file name for saving the FEM model. Run options change to Analysis. Click on OptiStrut to run the model. Results. Click on the Set Page Layout at top right corner. Divide the screen into two parts. Left click in the right side part, it is configured with Hyperview. Click on Open File and browse a H3D file. Click Apply. Click on Contour and Apply. Change animation mode to Transients. Click on Plot Query from the main menu. Check the results file. Subcase. Result type. / Select the nodes. Choose direction. And press Apply. Displacements of 3 nodes are plotted against time. As expected, tip node has maximum displacement.